Alright, today I'm going to go over real quick on video the example that we did in class. Had the question about how do we get the angles, and I the answer that I gave was less than satisfactory. I know, based on the student's expression and the fact that I didn't really answer the question. So here I'm going to answer the question again. We had the same problem where we have this hook and we have a cable or something here with an applied force F2 of 150 newtons. And then we had another force down here, and it was out here in this direction. I think it's F1 is equal to 100 newtons. All right, and we were given the information that the angle here, that this angle here was about 10 degrees, and that this angle here was about 15 degrees. I know they're not to scale, but the numbers are correct. And the question is, we said, what is the resultant force and direction? Okay. And the concepts that we were using here is the idea of the parallelogram. Don't know if I spelled that correctly, but anyway, so because these are vectors, we can move them around. All right, and we can also represent the same system as F1, and then we have up here F2, and then we have this guy, FR, which we're trying to find. So automatically you should look at that and you can say, oh, that's very similar to the parallelogram that we have. And so the question is, what is this theta? And what is the magnitude of FR? So in order to know FR, we need to know this angle, which we'll call gamma. And in order to get gamma, we need to be able to relate it back to the information that we've been given. And so over here, we have this x-axis, and we have this F2, we have F1. I'll try to make it more here, F1, so this is 15, this is 10, and then what we can do is come up here and draw a parallelogram. Okay, and so we know that this angle here is going to be 65 degrees right here. It's got 65 plus 10 plus 15 is equal to 90. And this is going to be 65 degrees. And then the sum of the interior angles needs to be equal to 360 degrees. So we can just say 360 minus 2 times 65 over 2, and that gives us 115 degrees. Okay, so that means we know this angle here, which is 115 degrees. And then this is the same angle that we're going to use over here. And hopefully that's clear to everybody. And so we can use that angle then to say, FR is equal to the square root of F1 squared plus F2 squared plus minus F2 squared minus 2F1 F2 cosine of 115 degrees. So good. So we all should be on the same sheet of music there. So now the question is, well, what angle here does F act relative to the horizontal axis? So what is theta? And so we can find theta actually by just using the law of sines and what's given. So now we have FR because we just calculated it, and we have gamma because we solved for it here. So then we can use that information with the sine law, and we can get that or we can use F1 or F2, sorry, F2 over, so F2 is this vector, so it's going to be over theta. So that's the angle that we're looking for. So F2 over sine theta is equal to what we get over here, FR. That's 213, or actually it's 212.6 newtons. So then we can say that F2 over sine theta is equal to 212.6 newtons over the sine of 115 degrees. So then all we have to do is solve for F2. And we can do that just by saying, then we just need to solve for theta. And I actually think I made a mistake on this in class as well. But we can say that sine theta is equal to F2 over 212.6. Bring this over, bring this down, bring this up, times the sine of 115 degrees. And then so we can just say sine inverse of F2 over 212.6 times the sine of 115 degrees is equal to theta. And that's how we get to answer. So hopefully this has been a little bit useful and it might help you with your homework.